helping kids learn about tech and AI. Welcome back to another Techstination interview. I'm Fred Fishkin. With us from STEMpedia is Chief Visionary Officer Abhishek Sharma. Thanks for taking the time, Abhishek.
Thank you so much, Fred, for having me here.
And I love that title, Chief Visionary Officer. Pretty cool.
Oh, yeah. So that's more of a strategic role in deciding where the business should go and yeah. So it's more strategic, yeah.
You've just launched an AI and robotics kit for kids called Quarky, Quarky. Give us the overview of what it is, what makes it different from the other STEM learning toys that are out there.
Yeah, so I have one here, right? So Quarky essentially is an AI and robotics learning kit, which is designed for students in the age group of 7 to 14 years old. The idea behind that is we want children to learn about AI through activities which are completely hands-on. We don't just want them to read about AI or watch videos about AI. We want them to get their hands dirty. And that was the whole objective behind Quarky. We wanted to make project making in AI simpler. And of course, when we talk about AI, it's a combination of two different things. One, what can the hardware do? And number two, what can the program or the software aspect do? So we have bring both of these together with the help of Quarky, and there's an app called PictoBlocks, which comes along with it. And the application is the one which students will use to program or write instructions for Quarky. So this is Quarky. The board is the size of a credit card. This is probably, yeah, it's a pretty handy device, right? The idea is, yeah, that students should be able to write programs which allow them to interact in an artificially intelligent manner with their surroundings. For example, if I'm happy and I want the robot to behave in accordance to my expressions, the robot should be able to do that. And we want to make it easier for students to understand what goes behind the algorithm which can do that, right? So it should be very easy for them to write a program like that and then execute it on Quarky and make it behave in a particular manner. There are different kits on Quarky. There are different levels or different, what I'll say, okay, so different kits, different variants to Quarky. The first one is the Innovator Kit, which is essentially meant for students who are exploring artificial intelligence for the first time. So they can convert this robot into two different models. One would be a flat, right, a three-wheeled horizontal robot. And then you can shift this wheel here and you can transform it into a vertical robot. And with these two variants, students will be able to perform more than 30 different activities and learn about artificial intelligence. And that would include face recognition, voice recognition, and a plethora of activities. Then we have another slightly advanced kit that is called Quarky Ultimate Kit. The objective there is to teach artificial intelligence from the perspective of robotics. Now, in comparison to two variants with the Innovator Kit, there are more than 10 different robot variations in the Ultimate Kit. And those robots range from, can perform activities like picking and placing, moving around from here and there, right? And so I have a bunch of them here, a bunch of robot variants from out of those 10 here, right? So this one essentially is a robot which could imagine maybe an Amazon warehouse. It can pick and place boxes from one place to the other, right? Then this is a QR code driven robot. For example, you want to have an overhead camera and track movement of this robot from one place to the other, and you want it to pick things and place anywhere else. This can be done. And you can program the robot to do this on the basis of your voice commands, instructions you give over Alexa as well. You can make it work along with Alexa. So you can essentially give commands to Alexa and the robot can get something done for you. And we want kids as young as 7 years old, 10 years old, maybe before high school, to understand this and be able to make this.
What's the story behind it? How did this get started?
Long story short, I think over 4 years of working closely with the customers and understanding the market needs, right? So we have been working since 2017 on this, like formally on this startup. And we started And we have taken up different challenges to solve when it comes to uh, making it simpler for students to make projects. The first challenge we took was how to simplify making electronic circuits. We came up with a product that was this big, an electronic prototyping platform called Evive in 2016. We launched it on Indiegogo for the first time, and it became huge. That is when we realized or gained confidence that yes, we can take up problems of how to simplify different aspects of learning by doing or project-based learning for children, and we can create solutions for them. So that electronic device was the first one. Then we expanded into creating a programming software, programming application, a bunch of learning resources. We launched programs for after-school activity centers, for educational institutions, and created what you see as STEMpedia today, which essentially is an ecosystem of quite a lot of tools brought together at a single place, all with a single aim. We want children to learn by making projects. And
why is it important for them to know these things?
otherwise, you don't get the real picture. See, what you learn at school, what the books teach you, it's very important from a theoretical perspective. But there is always a gap between what you see in the books and what happens in the real world, right? Technology in the real world progresses way faster than the curricula would progress, right? The curricula would stay same for 5 or 10 years while SpaceX would launch another dozen different rockets into the space. And you would want to understand how what you're learning in books is relevant to the real world, right? And this bridge is where we are functioning. We want their basic curricular understanding. We want to use it as a base, then teach them certain things which bridge the gap between the, I think, the curricula and the real world applications. And this goes through robotics, through IoT, through artificial intelligence, and probably any other new age technology which will come over the new years, right? Over the coming years. So yeah, I have another interesting thing for you. A Mars rover model.
Very cool.
And this is inspired by NASA's 2020 Perseverance rover. The design, the mechanisms, and everything is like that. So now if you want this to work on your voice commands, your facial expressions, and maybe probably find water on an artificial Mars you create at your home lab, it can probably do it.
And with these kits, they're reusable. Kids can take apart something they've made and start over again.
Absolutely. The kit is designed to be reconfigurable, reprogrammable, so you can do dozens of activities using a single kit. That is the objective behind it.
So tell us, you're coming to market with this. You've gone on Kickstarter now, but you've already designed these and manufactured some. So tell us what customers should know here. You've got different kits and different pricing. Tell us about it.
All right. So for the customer, so I'll probably try to define how the whole product range is structured and what it will mean for the user, for the student who wants to learn AI and robotics, right? So there are two basic base kits. One is the innovator kit, as I mentioned, right? One kit with 30 plus activities on 2 different robot variations. And all of these activities will be around understanding basics of artificial intelligence. Then the ultimate kit, which has more than 50 activities across 10 robot variations, which deal with slightly more advanced aspects of artificial intelligence, slightly more advanced aspects of robotics. They sort of merge these industry standard applications into a student's DIY project making world, right? Now, these are 2 bases here. Now, on top of that, when the student wants to go specific and spend their time learning more about a single application of AI and robotics, for example, the Mars rover, this becomes an add-on kit. They can get an add-on and they can perform around 10 different activities with the Mars rover, right? And the add-ons are not just limited to Mars rover. There's one with a humanoid as well, right? So one add-on would be a humanoid kit. So you can perform about a dozen different activities, make it dance, like program it according to uh, being probably a traffic policeman, right? Something like that. So yes, and then there are a bunch of other add-on kits which are under development. One would be a quadrupod, one would be a robotic arm. The idea is that the students' understanding should start from the very basics when they are interacting with artificial intelligence and electronics combined together for the first time, and then to grow as close as possible to the industry standard concepts.
Tell us where pricing begins and when you'll have these products in consumers' hands.
So that's a pretty interesting question. So for the Quarky Innovator Kit, just to understand how Quarky would behave and how the market would work around, we already produced around 2,000 kits and handed it over for beta testing. There are more than 100 institutions like maker spaces or teachers who are working with students to get their feedback on it. And around approximately 2,000 kits like that have been distributed in beta testing. Now, this hints that we already have the capacity to manufacture, right? We already have the product in place. The idea is we want more feedback. Now, the reason we launched the Kickstarter upon being confident that the product is working, after incorporating the feedback from all the students and educators across the globe, right? So, yeah. And coming to the pricing point, we are offering the Innovator Kit for $49 on early bird on Kickstarter, and the Ultimate Kit at $79 to begin with. And add-ons can range from anywhere between $30 to $70, $80, right? And the market price, of course, we want it to be like a 2-digit number when it goes on Amazon. So we'll probably be selling it for $99 on Amazon. Yeah. So that's the goal. But for Kickstarter audience, it will be $49 for now.
And for people who are going on Kickstarter and ordering, when will they get the product?
We'll ship in early October. So our shipping plans are that in the first half of October, we'll be able to ship up to 2,000 units. And in the second half of October, we should be able to ship another 2,000 to 3,000 units and rest in the November. So we are already prepared to manufacture 10,000 units, right? And yeah.
Are you being hurt by the supply constraints that we're seeing all over in the electronics industry?
Absolutely. So yeah, to answer that question, we already have the experience of doing 2 crowdfunding campaigns previously, right? And we know that shipping it on time and understanding the manufacturing risks and challenges is very, very important, right? You promise your customer that my product will be there in 3 months, and you didn't just realize that the plastic could warp around in injection molding, and it took you additional 2 months to sort it out. That hits brand's trust, brand's reputation. So we wanted to be absolutely sure that we are going to get the manufacturing through in the first attempt before even launching the Kickstarter. So as I mentioned, we've already tried manufacturing, or we have done manufacturing 2 rounds. We have been successful in doing them before even launching Kickstarter. Yeah.
Well, congratulations on the innovations, and I'm sure lots of kids, teachers, and parents are going to be enthusiastic about it. The website for more information is the STEMpedia.com, THESTEMPEDIA.com. Abhishek Sharma, thank you for taking the time with us.
Thank you so much, Fred, and thank you for having me there.
Now this. It takes a lot of listening to build a better radio, and that's just what the folks at C. Crane have done. Bob Crane and his crew, nestled among the rivers and tallest trees in the world in Fortuna, California, have made a habit of listening to their customers. And that's just what they've done in building the CC Skywave SSB, the Swiss Army knife of portable radios. For everyday listening to AM or FM in the yard or patio or on the nightstand, without having to drain a mobile phone battery, it's a great companion. But it is also a companion equipped for NOAA weather information and alerts that can be life-saving. You can listen to FEMA and Coast Guard transmissions too. Beyond all of that, you can tune into shortwave signals from around the world. It's compact, easy to take with you, and built to last. The CC Skywave SSB Click on the link at Techstination.com.